Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So today we are going to deal with the lecture number 4 of the simple harmonic motion. So in the last 3 sessions of simple harmonic motion, we understood what is SHM, what are the basic terms related to the SHM, and we did n number of questions and what is the energy in SHM, the kinetic energy, potential energy, the total energy, right? So these concepts were clear, right? So now we are going to the next phase of the simple harmonic motion. So that is finding the time period. Especially we are going to find the time period for the spring mass system, which is important, and the questions were asked in the previous years. So in JEE and NEET. And next we'll go for the simple pendulum. Okay. So then we'll go for a floating body and then liquid column. So tunnel questions. So all these concepts we are going to cover in the next 2 sessions. So this 4th session and 2 more sessions I will conduct. So with that we'll wind up the simple harmonic motion. So whatever the difficult part was there in the SHM, so that we dealt in detail already. Okay, if you understood the basic terms related to the SHM or the projection of uniform circular motion as the SHM and the energy in SHM. So based on those topics only, most of the times the questions were framed in the previous years. So the another important part is this one, which is the spring mass system. Okay, so we'll discuss this part in detail. So I just need your attention for the next 1 hour, guys. Just be with me, avoid all the disturbances around you for the next 1 hour, and at the end of the lecture it's very important to prepare your own short notes. And when you are coming to the next class, you guys should compulsory revise the previous class notes, and not only the previous class, so the whole chapters, whatever the chapters that we covered, you have to revise that short notes. Okay, clear? Chalo. So without wasting much time, let's get into the today's topic of interesting topic, that is finding the time period of any SHM. So steps to find time period of any SHM. Okay, so first we will consider the spring mass system here. So there are 3 basic steps that we have to follow to find the time period of any SHM. So that is first find the equilibrium position where net force acting on the body is 0. Find the equilibrium position where the net force acting on the body is 0. So first understand the steps, then I will do the example so that you will get the clarity. So then displace it from the equilibrium position slightly by some displacement x. Okay, so then find the net force again now. So after displacing from the mean position or the equilibrium position, so then express net force in the form of F is equals to minus kx. So these are the 3 steps. So I'll explain with simple spring mass system. See, this is the spring which is hung from a fixed end. So this is a fixed end. So now when you release this mass, this is a mass m. So now when you release this mass from this position with the spring, so what happens? It oscillates for some time. The basic thing practically what happens when this is a spring, let's suppose. So then you attach a mass to it. So then you released it. That means you left that. So then what happens due to the weight of the block? So the spring will be stretched. So it will not stretch at a time. What it does? It does SHM for some time. Yes or no? So then after some time, so it will cool down and the spring elongates and it will come to rest at this position. So that's what happens, right? So then we have to find the time period. Okay. So first I'll take, this is the initial scenario. Consider this is the initial scenario. Mass is placed, attached. So now you release the mass. So when you release the mass, so the spring oscillates and then it comes to rest after some time t. So that means the spring elongated by some displacement, let it be some x naught. So this is the original, and here, so this is displaced by x naught. Okay. So now it is in the equilibrium position. So this is in the equilibrium position now. This body is in equilibrium position. This point understood? Now at equilibrium position, find the net force acting on the body. So I can say that the body's weight mg is acting downward, and in the spring, so there is a force always that is called the restoring force, which acts always towards the equilibrium position or the mean position, right? So as the spring is stretched, so the spring force will act upward. So what is that spring force? Already we studied this in Newton's laws of motion as well. The spring force that is equals to kx, which acts upward. Yes or no? Here it is displaced by x naught, so the spring force that acts upward towards a mean position is the kx naught. So then I can say here the spring force is balanced by the weight of the block, then only it will be in equilibrium position, right? So in the second case I can write here, so the kx naught, the spring force, is balanced by the weight of the block, so which is mg. So now let it be. So this is the second step. So now get back to the steps. See here. So first find the equilibrium position where F net is equals to 0 on the body. So this is the equilibrium position where F net is 0 on the body. So now what we have to do? So we have to displace the body slightly x from its mean position. So now this is the mean position actually. This is the mean position or the equilibrium position we call. So now from the equilibrium position, displace the body by some displacement x. So here fixed position, then so let's say the block is here now. So you displaced it by some x. Already this, see, from here to here the displacement is, from here to here already the displacement is x naught. Now again from here, so this is already x naught we know. Now this is x. So now what is the total displacement of the body from the original position? X plus x naught. So now towards the mean position, so there is a force because the displacement is downward. So there is a force. What is that force? K into, so this time the total displacement is x plus x naught. So the total displacement is x plus x naught, and it should be balanced by the weight. So what is the weight of the body? Still mg. Yes or no? So this point understood, everyone? Is this point clear? So if you understood this one, the question, the procedure is done. So then I can write, so in the third case, the k, the spring force, that is the k into x plus x naught is equals to, so the mg. Here, see here, k into x plus x naught, the spring force, is balanced by mg, right? Done. Now we have got, I can write here, the kx plus kx naught is equals to mg. The kx plus kx naught is equals to mg. So can we write this? The third case we just displaced it by, so some more displacement x. So now the new spring force is what? So k into x plus x naught. And what is the new force that is acting, the weight that is acting downwards? The only force that is acting downward is the mg, right? So then I can write this one, kx plus kx naught is equals to mg. So then here what is kx naught? What is kx naught? Kx naught is already mg, we know that. So the kx naught is already mg, so which is equals to mg. So then the net force is equals, sorry guys, this time it is not in equilibrium, right? My bad, sorry. This time it is not in equilibrium, right? So the body force k into x plus x naught is more. The spring force will be more and weight will be down. So the force will be more. The net force I can write, my bad, very sorry. So the F net is equals to k into x plus x naught minus mg. Shall I write? Why? At the equilibrium position only these two will be equal, because the body is in equilibrium force. Upward force and downward force both are equal. But here the spring is displaced from its mean position. The force will be more, right? The weight will be less and the net force will be more, obviously. So that's why. So the F net is equals to k into x plus x naught minus mg. So now let's do this way. The F net is equals to kx plus kx naught minus mg. Done. So from here I can write here, so the f net is equals to, so kx, so here in place of kx naught shall I write mg? Yes or no? In place of kx naught I am writing mg minus mg here. So mg gets cancelled. So from here, so the f net is equals to kx. So we got f net is equals to kx. Fine. Chal. So now once we get the f net, so we have to express this f net in the form of f is equals to minus kx. So here if you observe, the force and the body's displacement, they both are in the opposite directions. The net force is upward, body's displacement is downward. So that's why, shall I write this force as f is equals to minus kx? Shall I write this as f is equals to minus kx? So now we got this. So we expressed this as f is equals to minus kx. Now how to find the time period? This calculation is important. See here. So the time period formula is actually 2 pi by omega. Right? 2 pi by omega. Now we got the k. Whatever the k that is there, the coefficient of x is the k. So then, so this k is equals to m omega square. We already know that. And from there omega square is equals to k by m, and omega is equals to root over k by m. Right. So chal. So here the time period will be 2 pi in by, so in place of omega, so I am writing root over k by m. So then the time period t is equals to 2 pi into root over m by k. So the time period t is equals to 2 pi into root over m by k. So this formula you have to remember. So see, in this particular case, the simple spring mass system, we got f is equals to kx only. In place of k, we got the k itself. But sometimes it can be 4k, sometimes it can be 3k, depending on the system. So we expressed this as f is equals to minus kx. Why? The displacement and the force are in opposite directions. So I expressed this as f is equals to minus kx. In place of k, so it can be something as well. So that k value we have to substitute it here. Where? Here. Understood? Then we get the time period. So now in this particular case, it's going to be simply 2 pi into root over k by m. Right? Sorry, m by k. Root over m by k. So now, so in place of k, we have k only. So here the time period of a simple spring mass system. So that means if a mass is attached to a spring, so then the time period of that spring mass is going to be 2 pi into root over m by k. So if you observe here, the time period is, so it is directly proportional to the mass. So that means the t1 by t2 is equals to root over m1 by m2. So based on this, the questions will be framed. Important. So this point is very important. And then, so the next one, the time period is inversely proportional to the spring constant. So the time period is inversely proportional to, so the root k, not just k, so it's a root k. So then I can write the t1 by t2 is equals to root over k2 by k1. k2 by k1. So this is also important point for the numericals, especially to solve the questions. You should understand these tricks. The final formula you already know, but question solving is important, right? And one more thing, so the frequency is inversely proportional to the time period, or time period is inversely proportional to the frequency. So I can write the f1 by f2, so will be equals to t2 by t1, which is also equals to, if the time periods, if you know the masses, so the t2 by t1 means I can write root over m2 by m1, or so which is also equals to, I can write, so the t is inversely proportional to k, so here it is k1 by k2. So this logic you should catch to solve the numericals. Okay, so in the simple spring mass system case, the time period formula you can directly go for 2 pi into root over m by k. Okay, So the procedure also I have explained. So but mostly they'll ask based on the simple spring mass system. That means a mass is attached to the single spring which is hung from the fixed end. Okay, chalo. So these 3 points are very important to solve the numericals. So now we'll solve some questions so that you get the idea, better idea. So try this question along with me, guys. So what's the question says? Read the question properly first. The time period of oscillation of a mass m suspended from the spring of negligible mass, spring has no mass, negligible mass, is t. So when the mass m is attached, the time period of that spring mass is t. So if along with it another mass m is also suspended, the time period of the oscillation now b. So what they are saying, in the first case, so the mass m is attached, so the time period is t. Now so another mass 2m is attached, let's say another mass 2m is attached. So now what is the time period, t dash? So you know that just now we discussed that t is directly proportional to root m. Yes or no? So the t is directly proportional to root m. So let the time period in the second case be t dash. So then I can write t dash by t is equals to root over m dash by m. So root over, what is the m dash? M dash is, so 2m, the second mass is 2m by the first one's mass m. So m cancel, so which is equals to root 2. So the t dash by t is equals to root 2. So from here, so the t dash is equals to the t into root 2. The t dash is equals to t into root 2. So that means option 4 is the correct one, guys. Understood this one? Basic concept, basic question. Chalo. So we got one more question. So try to understand this question first. A mass m is vertically suspended from the spring of negligible mass. So the system oscillates with a frequency n. So what will be the frequency of the system if mass 4m is suspended from the same spring? So see here, the frequency and mass we have to relate, that's it. So in the first case, the mass m is attached. See here, only m mass is attached. So the frequency f, let it be equals to n, that they gave it as n. So now what will be the frequency of the system if a mass 4m is attached? So if a 4m is attached, so this time, so the mass is 4m. So let the frequency f dash. So what is this f dash value they are asking? Okay, so how do we find? So we know that the time period is directly proportional to root m and inversely proportional to root k. And then, so the time period is inversely proportional to f. The time period is inversely proportional to, let's write this way. You remember this relation so that you can solve the questions easily. So the time period is directly proportional to root m, inversely proportional to root k, and then it is inversely proportional to f. Okay, so from this any question can be solved, guys. So now we need the frequency and the mass relation. Yes or no? So here m mass is attached, frequency n. So if 4m mass is attached, what is the frequency? So we have to establish the relation between these two now. That's it. So that means, so the frequency is inversely proportional to 1 by root m, I can write. The time period is directly proportional to root m, means the frequency will be inversely proportional to the root m, obvious thing, right? Chalo, so now the f dash by f is equals to root over m by m dash. Root over m by n, f dash by f is equals to root over m by m dash, inversely proportional to the root, right? So then, so the square root of, so what is the m? The first one in this case, so the mass is m. So the second case, m dash is 4m, right? Chal. So f dash we have to find by f is n. So the f is n, so which is equals to m gets cancelled, so root over 1 by 4. So the f dash by n is equals to so 1 by 2. So from here, so the f dash is equals to, so n if it goes to that side, so n by 2. So that means the frequency in this case will become n by 2. Option 2 is the correct answer. Clear? So this relation you should understand, so that you can solve the questions very easily. Understood guys? Clear? Chal. So let's move further. So we got one more question. Can you guys try this? What's the question says here? A body of mass m is attached to the lower end of the spring whose upper end is fixed. Okay, so lower end m mass is attached, upper end is a fixed one. So the spring has negligible mass, so spring mass is neglected. When the mass m is slightly pulled down and released, it oscillates with a time period of 3 seconds. So when the mass is m is increased by 1 kg, so the time period of the oscillations become t, 5 seconds, sorry. So the value of m in kg. So try to understand the question. So in the first case, let's say the mass m is attached. So now when you displace it from the mean position or when you release it from the rest, so then it oscillates for a time period of 3 seconds. So the time period in the first case is 3 seconds when mass is m. Now, so when the mass m is increased by 1 kg, so in this new scenario, the mass m is increased by 1 kg. That means, so it is m plus 1. The mass is now m plus 1. Okay guys? Chalo, just a minute. Okay. So the mass is, it is m plus 1. So now, sorry. So now here the time period is how much? So that's what they, sorry, the time period is given, mass they are asking, right? So the time period t2 let it be. So here t1 3 seconds. So the t2 which is 5 seconds. Okay, chalo. So that means we know the relation between the time period and the mass. In the question they are asking the what is m value. So we know the time period in two cases. When mass is m, we know the time period. When mass is m plus 1, we know the time period. So what's the relation that we know between the time period and mass? The time period is directly proportional to root over m, r, so which is inversely proportional to root k, r, so which is inversely proportional to the frequency. This thing you should keep it in your mind. Understood? Chalo. So now I need only this part for this particular question. So what I will do, the t2 by t1 is equals to root over m2 by m1. Yes, chalo. So then what is t2? So the time period in the second case is 5 and the time period in the first case is 3. So what is mass in the second case? M plus 1 by what is mass in the first case? M. So then square it on either side, 25 by 9, 5 square by 3 square, squaring on either side, 25 by 9, which is equals to m plus 1 by m, right? Chalo. So then I can write here, so the mass value that they gave, no. So I need what I need? The value of m in kg. So the only unknown is m. So let's do one thing, m plus 1 into 9 cross multiply is equals to 25m. Fine. So then this is going to be 9m plus 9 is equals to 25m. So from here, so send this to that side, 9 is equals to 25m minus 9m, so which is 16m. So from here, m is equals to 9 by 16. So the m value, it is equals to 9 by 16. Option 1 is the correct one. Understood guys? The concept is clear? Sure. So just note this down. So we have got one more question. So can you guys try this? If body of mass 5 kg hangs from the spring and oscillates with a time period of 2 pi seconds. So a body of mass 5 kg. See here. This is a body of mass 5 kg. So now it is hangs from a spring and oscillates with a time period of, the time period is equals to 2 pi that they gave. Fine. So now in the second case, So if the ball is removed, that means the mass is removed. So this time there is no mass, mass is removed. So then the length of spring will decreases by. So the length of spring will decreases by. So how much? See, when the 5 kg mass is attached, let's say, so it is displaced by some x naught when the 5 kg mass is attached. So to get the equilibrium position, let's do one thing from here to here. So when you release this one, so when it comes to equilibrium position, the 5 kg mass, so then it is suspended, it is extended by x naught. So when you remove this 5 kg mass, again it goes back to the mean position. So again it comes to its original position. So if there is no mass attached, so that means what is the elongation in the spring? X naught when the mass is attached. When you remove that mass, so again it will come back to its original position. That means its length decreases by x naught. So we have to find what is this x naught. We have to find what is this x naught. So we know that the time period is equals to 2 pi into root over m by k. The time period is equals to 2 pi into root over m by k. So then here what is this k? What is this k? How do you find the k value? So the net force F is the kx naught actually is equals to mg, which is 5g at the equilibrium position. So let's suppose it is hung by some displacement x naught. So then the kx naught which acts upward, here the force acts is kx naught, and then here the force acts is mg. So this is the equilibrium position. In this particular case, I can write the kx naught is equals to, so the 5 mg, so which is nothing but, so kx naught is equals to mass is 5 into g. Okay, so from here shall I write, so the k is equals to 5g by x naught. The k is equals to 5g by x naught. So what I actually required, I need the x naught value. So what I will do is I will substitute that k value here, 5g by x naught here. So in place, so time period is equals to 2 pi into root over, so let the mass be mass. In place of k I am writing 5g by x naught. So understand the things carefully. So then, so what I will do here, so the time period they already gave it in the question. So the time period is 2 pi. So in place of time period I am writing 2 pi, which is equals to 2 pi into, so root over, so this x naught will go up, x naught into m by 5g. So let's do one thing. So 2 pi cancel, here 1 is equals to root over x naught, let it be. So in place of mass shall I write 5, because the 5 kg mass is attached. So here 5 by 5g. So then 5 cancel, then so root over x naught by g is equals to 1, squaring it on either side. So we can write x naught by g is equals to 1 from here. So the x naught is equals to g into 1 is g. So that means it decreases its length by g meters. So it decreases its length by g meters. Option 4 is the correct one. Understood everyone? Clear with this? Chalo. So this question, see here. Can you guys try this? What's the question 5 says? Two bodies m and n of equal mass are suspended from two separate massless springs of force constants k1 and k2 respectively. So see here, so this is the first spring whose force constant is k1. So two bodies of m n of equal masses, let's say this is of m, so of mass let it be m. So then there is another spring, so which is of same mass, so but the system is let it be n, so it has a spring constant k2. So fine, if the two bodies oscillate vertically such that their maximum velocities are equal, try to understand this line. So then the ratio of amplitude of m to that of n here, so when you release these masses, so they does SHM. That part you know, right? When you release this mass and this mass, so what happens? They does SHM. They oscillate about their mean position, right? So when they are oscillating, they are saying that the maximum velocities of two bodies are equal. So you know that the maximum velocity while doing the SHM V max is equals to A omega. Remembered this part? We dealt it in the lecture number 2, basic terms related to SHM. So here the V max of body M is equals to, so the V max of body N, that's what they are saying. Now, so what is the V max formula? A omega. So that's why I am writing A of M into, so the omega of M is equals to, so A of N into the omega of N. Done. So what we actually need? We need the AM by M to that of N. So which means AM by AN I required. So which is equals to, so omega, so AN by, sorry, omega N by omega M. AM by AN. So I brought it to this side. So then omega N by omega M. So now what is omega? In terms of K we have to write. So we know that the time period is equals to 2 pi by omega. So then omega is equals to 2 pi by T. Right? So what's the time period formula? So the T is 2 pi by, in place of T we can write 2 pi into root over M by K. So now 2 pi cancel. So the omega will be equals to root over K by M simply. So here, so root over K by M for this and root over K by M for this. So this one cancel. So the K of N, what is K of N? K2 by K of M, K1. So root over K2 by K1. AM by AN is equals to root over K2 by K1. You understood this part now? Time period is equals to 2 pi by omega. So then what is omega? Omega is equals to 2 pi by T. So then 2 pi by T is what? 2 pi into root over M by K. So 2 pi cancel. So this will go up. So the omega is equals to root over K by M. Or else you can need not to go for that also. You can directly do this way. So you know that K is equals to omega square. From here, what is omega? Omega is equals to root over K by M. Omega is equals to root over K by M. So that means in place of this I can write K by M. So Kn of Mn. So Km of Mm. You can write that way also. If you need, I'll write in detailed step. So if you are getting confused. So omega n, which means, so root over Kn by Mn by, so omega m, which is Km by Mm. So they said they both have equal masses. So two bodies they are having, so equal masses. See here, yeah. So the Mm and Mn are cancelled. So then the Kn by, I can write Km. So Kn, what is Kn? K2 by, what is Km? K1. Understood? So the pictorial representation and the basic terms knowledge is very important, guys, while solving the questions. Done? Clear? Chal. So the case 2, in the previous case, so what we have seen, the time period is what? 2 pi into root over M by K. So when the spring mass is like this, vertically hung from a fixed end. Now, so what if it is on the horizontal? So if it is on the horizontal surface, so then it is already in equilibrium position, I can say, because it is supported by the ground or some platform, whatever it is. So it is already in equilibrium position. So that means it's already in step 1. What is the step 1? The first one, see here. So find the equilibrium position where F net is 0. So in this case, it's already F net is 0. So in this case, it's already F net is 0. Okay. So now you displace it from the mean position. So this is a mean position. let's say if you displace it by some x, so then what happens? So here the spring force will act. So what is that spring force? Let's say if you displace it by x, the spring force that acts towards some mean position is kx. So the F is equals to kx already. So as the force and displacement are in the opposite direction, I can write F is equals to minus kx. So in this case also I got in place of k only. So the time period will become what? So 2 pi into root over m by k. So in this scenario also the time period will not change. The time period is not getting changed. Understood? So whether the spring mass system is vertically hung from a fixed end or it is placed on a horizontal surface like this with a fixed end, with the one end of the spring is attached to the fixed end, another end is attached to the mass. So in both the cases the time period will be the same. And in the third scenario, that is if the spring mass is placed on a inclined plane, so one end is attached to the fixed end, this is a fixed end part, and another end is attached to the mass. So in this scenario also, so the time period will remain same. The time period t is equals to root over 2m by k. So write it as a conclusion, whether it is here also 2 pi into root over m by k. If you want, we can do the derivation, simple thing. So already it is not in the equilibrium position originally, because there will be some force which is acting. What is that force? So mg sin theta is acting, right? So now when you displace it, let's say if you displace it this side, so by some x, so then the force acts this side is a, so the kx towards its mean position, so then what happens, that kx is equals to mg sin theta. So then already the original force is mg sin theta. So if you calculate that, we get the again the same thing, k in place of f is equals to minus kx only we get here also. Okay, no need of derivation, just go for the basic procedure. So the time period will be again the same in this scenario also. So that means the three situations, if the spring mass is spring is attached vertically like this, so in this case the time period is 2 pi into root over m by k. Or so if the spring is attached so like this, so in this case also what's it, mass m, so the time period t is 2 pi into root over m by k. Or the third scenario, so when it is placed on the inclined plane, so then also the time period is 2 pi into root over m by k. So in all these scenarios, and there is a special case, so that is a 4, when so the spring mass, like it is attached to the fixed end and then a pulley is placed here, and over the pulley a mass m is attached. So in this case the scenario changes, the time period will not be equals to 2 pi into root over m by k. So let's try solve this one, you'll get the idea how to solve. See, so first when it is, let's say mass m is released, so when the mass m is released, what happens? So mass m is released, that means it is, try to understand this part guys. So it is originally here, now it is displaced by some x displacement. So then here it is the fixed end. See, if it is displaced by x, in the Pulley questions of Newton laws of motion we have solved already. So if it is displaced by x, so the total length it comes out to be, so the total, let's say if it is x come down, so the spring will come down by x by 2, the elongation here it is going to be x by 2, because here this total length will be halved, like it will come down. So that means L, this will become 2L. So if it is x displaced by x, so here it will be displaced by x by 2. Or else if it is displaced by x, let's say, so then here x, total the rope will displace by 2L. So that means if it is displaced by x, this will be x by 2. So then the spring force that acts upward, that is kx by 2. This part is clear because this side and this side, so total x. So but here it is only x by 2. Understanding? Or else you understand this way. So if the spring has come down by x, so this will total come down by here x, total 2x will come down. So if I consider here x, this is going to be x by 2 simply. Understood? Chal. So now this kx by 2 is balanced by what? So here the tension force and here the tension force. So the 2t is the tension force which is balanced by kx by 2. The 2t is the tension force which is balanced by kx by 2. So what's the tension here? So the tension T is equals to mg. The tension acts upward, mg acts downward. So the tension T is what? Mg, right? So which is equals to k into x by 2. So from here what we need actually? We need the k value. So from here I can write, so the kx is equals to 4 mg, right? So then x is equals to, what is this? 4 mg by k. The x is equals to 4 mg by k. So now you have to represent it in f is equals to minus kx form. So how do you represent it in f is equals to minus kx form? F is equals to minus, force is upward and the displacement is downward. So which means in place of k, what do we have? The coefficient, see, or else you just write this way. So the total, let's write this way. So the 2 mg is equals to kx by 2. So just a minute guys. So the mg is equals to kx by 4. The weight mg is equals, this is a force, right? This is a force that acts downward, that mg is a force that acts downward. So which is equals to kx by 4, which is nothing but k by 4 times the x. K by 4 times x. So let's write this way. So now represent this in the form of f is equals to minus kx. So what is f? Force is upward and the displacement is downward. So I am writing this as f is equals to minus k by 4 times x. So which means the f we represented if it in the form of f is equals to minus kx. Here k is not equals to k. Here it is k by 4. So now what will be the time period becomes? So the time period is equals to 2 pi into root over m by k actually. So in place of k what we have to write? K by 4 we should write. So the 2 pi into root over m by, in place of k I am writing, so k by 4. So this k will go up. So 2 pi into root over, so 4m by k. So what is this? The time period of the special case, so which is root over 2 pi into 4m by k. Understood guys? Everyone? Clear? Chal. So note this down once. First. So in the three cases it's going to be 2 pi into root over m by k only. But the special case, the fourth one, so you can directly remember 2 pi into root over 4m by k. Done? Chalo. So now the combination of springs. So we already learned this in the NLM. So this combination is said to be the series combination of the springs, where so the two ends of the one end of two springs so will be connected one to the another. So the first end of the first spring and end of the starting of the second spring, they both connected at common point. So here also you can see that, so one spring end, the another spring starting, they both connected. So this is said to be the series connection. Okay. So here I can write, in the case of series connection, the equivalent spring constant. So let's say this has K1, this has K2. So then the series connection, the equivalent spring constant 1 by Ke is equals to 1 by K1 plus 1 by K2. 1 by K1 plus 1 by K2. So or you can also write it for the two springs which are in series combination directly, K1 K2 by K1 plus K2. K1 K2 by K1 plus K2. So if the two springs have equal, spring constants, if two springs have equal spring constant, if the two springs have equal spring constant, so then I can write, so the K equivalent will be equals to, so K by K plus K, K into K, K square by K plus K, 2K. So K cancel, K by 2, or simply if n number of springs, if they are connected in the series combination with equal spring constant, so the K equivalent is equals to K by n, you can write. So if n springs of equal spring constant are connected in series combination, equal spring constants, if they are connected in series combination, so the K equivalent will become K by n. So the K equivalent will become K by n. So here it is K by 2, here it is K by n. So if 3 are connected, K by 3. If 4 are connected, K by 4. If 5 are connected in series with the equal spring constant, K by 5. So like that. Understood? Chalo. So and the parallel combination of the springs means, so the both the ends will be connected to the different ends. See here, one end connected to the fixed end, the other end connected to the mass. So one end connected to the fixed end, another end connected to the mass. Or else it can be like this, one end connected to the fixed end, the another end connected to the mass. So one end connected to the fixed mass and another end connected to the fixed end. So these are the different ways you can identify the parallel combination, or you can understand that, so the mass comes in between like this. So the mass comes in between, or so for the mass the two springs will be attached this way, one end another end, one end another end. That means in the series combination, so the two ends will be connected at one point of the two springs, right? But here there is no connection between the two ends of two different springs. So this one between the two fixed ends, this one between the two fixed ends. So these two ends between here, so these two ends here, like this. So these are the parallel combination. So in the parallel combination, the K equivalent will be equals to K1 plus K2. So if the two springs having the spring constants K, equal spring constant K, so it will be 2K. So if n springs of equal spring constants K connected in parallel combination, so then the K equivalent will become n times a K. The K equivalent becomes n times a K. That's it. Hope you understood what is a series and parallel combination now. So let's see some simple questions based on this. You guys can solve them very easily. So two springs of spring constant K1 and K2 joined in series combination. So the effective spring constant for the combination is given by, in the series combination, so we know that 1 by K equivalent is equals to K1 K2, sorry, 1 by K1 plus 1 by K2 series combination. Resistor series, the springs parallel. Resistors parallel, the springs series. So resistors series, capacitors parallel. Resistors parallel, capacitors series. Okay, remember that. So in the second year you learn the capacitors concept also. There also the capacitors connected in the series combination, parallel combination will study. Okay, already 12 students and droppers, they know it very well. So here, so K1 K2, so I can directly go for the formula, right? The K equivalent will be equals to K1 K2 by K1 plus K2. However, they did not give the values, so directly the formula K1 K2 by K1 plus K2, option 4 is the correct answer. I could see that. Done. So a man M is suspended from the two coupled springs connected in series. Okay, so the force constant for the springs K1 K2, the time period of the suspended mass will be, so what they are saying, so they are connected in series. So if they are connected in the series of the two springs are connected in series, means the K equivalent will be obviously K1 K2 by K1 plus K2. So this part is clear? Yes. So the time period of the suspended mass will be, so time period formula is what? 2 pi into root over m by K equivalent, you write it here. So in place of K equivalent, what we should write? So the time period T is equals to 2 pi into root over m by in place of K equivalent, so you just write this one K1 K2 by K1 plus K2, right? So then the time period T will become, so I can write here 2 pi into root over M into, so K1 K2, sorry, K1 plus K2 by K1 K2. Understood? Clear this part, everyone? So here I can write, so 2 pi into root over M into K1 plus K2 by K1 K2. So check for the option. Option 4 is the correct one, right? 2 pi into M into K1 plus K2 by K1 K2. That's it, direct formula based questions. So this question you can solve it now. So they are asking two springs of force constants K and 2K connected to a mass as shown in the figure. So the frequency of the oscillation of the mass. First, how they are connected? Series combination or parallel combination? One end to the fixed end, one end to the mass. One end to the mass, one end to the fixed end. So this is the parallel combination. That's for sure. So the K equivalent in the parallel combination will be, so first let's write. So the springs are connected in parallel combination. Yes. So now what is the K equivalent? So which is K1 plus K2. So K plus 2K. K plus 2K, which is 3K. Shall. Done. So then what we can write time period? So the time period is equals to 2 pi into root over M by K equivalent. So which is 2 pi into root over M by the K equivalent is 3K we got. So but we do not require the time period, we require the frequency. So frequency is what? So 1 by time period. So 1 by, so 2 pi into root over M by 3K. So which is nothing but 1 by 2 pi into, so this will go up. So 3K by M, that's it. So 1 by 2 pi into 3K by M, root over 3K by M. Option 3 is the correct answer, guys. Done? Clear? Chalo. So the next question here. So two identical springs of spring constants K are connected in series and parallel as shown in the figure. So a mass M is suspended from them. So the ratio of their frequencies of vertical oscillation will be. See here, this is a series combination first and this is a parallel combination, standard diagrams. So what I will do is, let's write separately. So first in the series combination and then let's write the parallel combination here. So let's do the simple calculations. So the K equivalent in the series combination will be K by 2. Then let the time period T1 here. So 2 pi into root over M by K equivalent. What is K equivalent? K by 2. So then, so 2 pi into root over, this 2 will go up to M by K. So this is the time period in the first case, but we need frequencies ratio. So what is F1 will become? So simply 1 by 2 pi into, so this is K by 2M, root over K by 2M. Let it be equation number 1. So then in the parallel combination, so the K equivalent will become, they both have the same spring constants. So K1 plus K2, K plus K, 2K. So then the time period in the second case, 2 pi into root over M by, so 2K. Done. So then what's the frequency in the second case? 1 by 2 pi into root over 2K by M. Just reverse. So let it be equation number 2. So now we need the frequencies ratio, F1 by F2. So F1 by F2. So which is equals to the first one, 1 by 2 pi into root over, what is this? K by 2M by K2. 1 by 2 pi into root over 2M by K. So 2K by M, sorry. 2K by M. So fine. So then, yes sir, correct only, right? So root over 2K by M. Yes, fine. Chalo, so now do the calculations. 1 by 2 pi, 1 by 2 pi cancel. So here in the root, so K by 2M into, so M by 2K we can write. So M cancel, K cancel. So it's going to be 1 by root 4, which is nothing but 1 is to 2. So the F1 is to F2 is 1 is to 2 is the correct answer. Right. So the 1 is to 2, option 1 is the correct answer. So or else you can directly go for the second method. The easiest method is the method 2. So in the method 2, so what we can do? We know that the frequency is equals to 1 by 2 pi into root over k by m. Root over k by m. Because the time period is what? 2 pi into root over m by k. So now here you can see that the frequency is just reverse 1 by 2 pi into root over k by m. So then the frequency, the 1 by 2 pi is a constant, and m, in both the cases the same mass is attached to m. So then the frequency is directly proportional to root k. So I can write f1 by f2 is equals to, so root over k1 by k2. So then I can write root over, what is k1? In the first case the k1 is what? K by 2 by, so in the second case the k, this one is 2k. So then this will become, so root over k by 2 into 2k, which becomes 4k. So k cancel, 1 by root over 1 by 4, which is nothing but again 1 is to 2. So the same answer we got by the both the methods. Understood guys? Clear? So this question you take it as a homework. So the simple question, take this question as a homework. Done. The time period you have to find in both the cases. It's a easy question, you can solve it. So then cutting off spring. So this type of questions, like the questions based on the cutting off the spring, we already solved it in the Newton's laws of motion. So again I'll explain. See, this is a spring of, let's say, some length L, the spring constant K. Now, so you know that the spring constant K is going to be inversely proportional to the length. So if I cut this spring into two equal halves, let's say, so if I cut this into two equal halves, so the length has become L by 2, let's say L by 2. So then the spring constant of it will become 2k. So here also the spring constant will become 2k, just reverse. Okay, or if I cut this spring into three equal halves, let's say, so the L by 3, L by 3, L by 3. So then the spring constants will become, so 3k, 3k and 3k. So the spring constant is inversely proportional to the length of the spring, or else. So let's say this is a spring of which is length L and spring constant k. Now it is divided into 2:3:4. So it is cut into 2:3:4 lengths. So that means, so the first one is, what is the first one length? I can write, so 2L by total 5 plus 9. So 2L by 9. The second one is cut into 3L by 9. 3 parts out of 9 parts. Yes or no? So then the fourth one is 4L by 9. Because total 9 parts, right? 4 plus 3 plus 2, 9 parts. So then I can write here the spring constant here it will become reverse. So 9 by 2k, and here 9 by 3k, and here spring constants 9 by 4k. That's it. So the spring constants will get reverse of the length. K is inversely proportional to length. Understood? Chal. So now you can see the questions based on the concept. So the time period of the mass suspended from the spring is T. If the spring is cut into 4 equal parts, so the same mass is suspended from one of the parts, only from one of the parts. So then the new time period will be, time period is directly proportional to what? You know that the time period is directly proportional to root over m by k. Yes or no? So what is the spring constant? When a spring is cut into 4 equal parts and the same mass is suspended from, see here, this is a spring now. So when the mass m is attached, so we know that the time period is t. So now the spring is cut into, this spring, the same spring is cut into 4 equal halves. So this is the one, and this is the one, and this is the one, and this is the one. So it is cut into 4 equal parts. So let's say L by 4, L by 4, L by 4, L by 4. So now the spring constants of each one will become 4k, 4k, 4k. The spring constants of each one will become 4k. So right. So then what is the new time period? When the total, if the same mass is not changing, if the same mass is suspended from one of the parts, so one part has time spring constant 4k, right? So let the time period in this case is t2. So the t2 by t1, or else let's do this way, the time period is directly inversely proportional to root k, because the mass attached is also same, 2 pi is also same. If the same mass is suspended from one of the parts, okay, so then the t1 by t2 is equals to root over k2 by k1. That's it. Done. So t1 is t, in the question they mentioned. T2 we have to calculate, so which is root over k2. What is k2? This is k2, 4k, only one part, so from one of the parts, so that's why k is 4k by, so in the first case k is k only, k cancel. So then the t2 is equals to, let's do this way, t1 by t2 is equals to, t by t2 is equals to root 4 is 2. From here the t2 is equals to t by 2. So the correct option is t by 2, option 3. Done? Clear? So you take this question as a homework. So the homework number 2, simple question, same. So here the spring is cut into 2 equal parts. If one part oscillates with the same particle, the time period will be same kind of question. So this question also you can take it as a homework 3. That's it. So total 3 questions as a homework, and we dealt the spring mass system concepts in detail. So in the next session I'll come up with the simple pendulum. So that's also an important concept, so that we'll deal in next lecture. So till then, keep studying. All the very best, guys. Bye.